Okay, let's look at number 17. So this is where we start to get into the nit and gritty. So what do we have to do here? Well, to solve this problem, it's asking us to find the length of the major axis, the length of the minor axis, the length of something called the latus rectum, don't laugh, and the eccentricity. Okay? To do each of these, what I need to do is I need to convert this into the previous format. So I needed to make it look like x minus h squared over a squared plus y minus k squared over b squared equals 1. And the way I'm going to go about doing this is I'm going to complete the square. Okay? So we're going to complete the square in order to make it look like the previous format. So how do we go about doing that? Well, the first thing I'm going to do is I'm going to take everything on one side and move it all to the other side. I'm going to take all these numbers and move it over. So I'm going to end up getting 2x squared plus 8x plus y squared minus 16y plus 52 equals 0. Okay, so the first move is to move everything over to one side. Now, also note, I kept it organized. I put all my x's on one side, put all my y's on the other. Okay, so I have all my x's here, I have all my y's here, and then I have the constant. And the next move is to move the constant to the other side. So all I'm going to simply do is just move the 52 to the other side. So when I do that, I get 2x squared plus 8x plus y squared minus 16y equals negative 52. Okay? Now is when we get into a little bit of the complicated part. We are going to complete the square. However, there's a caveat to completing the square. Completing the square only works when the leading coefficient is 1. If you look here, the leading coefficient in front of x squared is 2. So what I actually have to do before I complete the square is I have to factor a 2 out. Okay, I'm going to give myself a little space here. Plus y squared minus 16y. Give myself a little space here equals negative 52 plus some space. Ran out of space and give yourself some space there. Okay? You'll also notice that I didn't have to factor anything out of the y's because the y has a leading coefficient of 1. So because of that, I don't have to worry about that. Okay? And when you complete the square, you're going to want to be very careful here because it's not as simple as it seems. You're still going to do what we did for the circles. You're still going to take this value here, the value in front of just the x term, and the value in front of just the y term. And then you're going to divide by 2 and square it. So 4, I'm going to divide 4 by 2. That's 2. 2 squared is 4. Okay? What you have to realize is that you are not just adding 4. You are adding 2 times 4. So I have to put in 8 here. Okay? Because if you distribute this out, it will become 8 and not 4. And so what you're technically doing is you're adding 8 to the left side. So to balance the equation, you have to add 8 to the right. Now the nice thing is, when you take 16, you divide by 2 and you square it, that's all you have to do there. So negative 16 divided by 2 is negative 8. Negative 8 squared is 64. And then I'll add 64 to the other side. Okay? So as our journey continues, we're over here. And so this becomes 2x squared plus 4x plus 4 plus y squared minus 16y plus 64 equals 2. I'm going to clean up this. That's going to get 64 and 52 give me 12. 12 plus 8 is 20. Okay? So now, what do I have? Now, I have, let's see here, let's do it purple. Now, I have 2x plus 2 squared plus y minus 8 squared equals 20. Okay, if you're wondering what I did here, all I did was I took this value, when I divided by 2 I got this, when I divided by 2 I got this. Okay? So from here, what we do when, I think I have to go back to my, let's go with blue. From here, what we're going to have to do is we have to get this 20 to equal 1, so I'm going to divide everything through by 20, and I'll get x plus 2 quantity squared over 10 plus y minus 8 quantity squared over 20 equals 1. And now we can say that b equals the square root of 10, a equals to the square root of 20. Now I know square root of 20 is 2 square root 5, or square root of 4 times square root of 5, which breaks down to 2 square root of 5. But I think square root 20 sometimes is easier to use. Okay? So we're asked to find the major and the minor axis. So to match the way the format that the answer key has, I will use this format here. So remember, the major is 2 times the bigger, so 2 times this, 2 times 2 times the square root of 5, say that 3 times fast, 4, which gives me 4 square root of 5. The minor is 2 times the smaller one, which is the square root of 10, and that gets me, wow, 2 square root of 10. Okay, now we have this thing called the Latus Rectum. Yes, it is called the Latus Rectum. And what the Latus Rectum is the distance from the focus to a point on the circumference of to the perimeter of an ellipse. Okay, so there's a formula for this, and the formula to calculate the Latus Rectum is 2b squared over a. So all I have to do is revert back to my a and b. Remember, a is square root 20, b is square root 10. So this is going to be 2 square root of 10 squared over a. And you know what? I'm going to go ahead and use 2 square root of 5. 2 square root of 5. Okay? This actually is really easy to solve. The square root of 10 squared is 10, but the 2's here, they cancel out. So this leaves me with 10 over the square root of 5. Now we don't like that written that way, so what we do is we multiply both the top and the bottom by square root of 5 to rationalize the denominator. And we get 10 square root 5 over 5, which then cancels these 10 and 5 out and leaves me with 2 square root 5. And that's my answer. Okay? So your Latus Rectum has a length of 2 square root 5. Okay. Almost done. The only thing we're left is eccentricity. Eccentricity is how much stretch you have. The formula to find eccentricity of an ellipse is C over A. So all I have to do is, so if the formula for eccentricity is C over A, what I need to do is figure out what C is. So how do I figure out C? Well, remember, C is equal to A squared minus B squared is equal to C squared. And we know that A is square root 20 and B is square root 10. So what I usually do is I use this value because this is A squared and B squared, and we just subtract them. So we just have 20 minus 10 is equal to C squared. So 10 is equal to C squared, and square root 10 is C. So if I plug in square root 10 here, we're good. And then we look for A. A is, again, square root 10, or 2 square root 5. Here I'm going to use 2 square root of 5 because it's a little easier to work with. 2 square root of 5. And if you remember, with the square roots, If they match up, then you can just divide them. So this becomes square root 2 over 2. And there's my eccentricity. And what eccentricity does is it measures how much the ellipse stretches. We'll talk more about that later. But there you have it. So, what did we do? Just to review, here and here we completed the square. Okay. Then when we put it in this format here, I get my A and my B by square rooting those values. Major and minor is 2A, 2B. So this is 2A, and this one's 2B. The Latus Rectum is this formula right here. Eccentricity is this formula right here. And you just plug and chug and you'll get your answer. Alright, hopefully that makes sense. See you all in the next video.